So here's 11-3, sector area and arc length. A sector is the shaded portion over here. It's like a piece of pizza or a slice of pie. It's round here and it's an angle right here. And the sector is two-dimensional, so we're going to try to find the area of it. Arc length is a different thing. So fill in the definition. Sector of a circle is the region bounded by two radii, MA and MB, of the circle, and their intercepted arc, the arc right between them, or between the two radii. Now to find the area of it, it's going to be easiest if we just set up a proportion and we cross multiply. What you need to remember about proportions is that you keep the same thing across the top. So we're going to put the small piece on top, everything related to the sector on top, and the whole circle on the bottom. All the information related to the circles on the bottom, the small piece is on the top. We're going to be comparing two parts of it. The area of each versus the degrees over here. As we set up our proportion, then we can cross multiply. So think about the area. The area of the small piece is what we're going to be looking for. The area of the sector, A sector, area of sector. For the small piece, we have to think about the degrees of the center, and that's going to match whatever the central angle right here is. So it's the central angle. Now think about the whole circle. Things we know about the whole circle. Area. Think about what you know about the area of a circle. Pi r squared. That's what goes right down there, the area of the circle. But then think about degrees of a whole circle. You know how many degrees that is. An entire circle has degrees of 360. So that's what we're going to set up in order to be able to solve. So look at the example, keeping all of this in mind. So now we're going to find the area of this pink sector, and we're going to do it by comparing it and setting up a ratio to the whole entire circle. So on the left-hand side here, we're going to be doing the areas, and on the right-hand side, we're going to be doing the degrees. And remember that the small part goes on top, the sector goes on top, and the whole circle goes on the bottom. So that's going to be the bigger numbers. So we're talking about area. Looking at this pink sector here, we don't know the area, so that's going to be our variable when we're trying to find the area of the sector. But comparing that to the whole circle, the area of the whole circle we can find. The circle is pi times radius squared. That is pi times 16, that's the radius, 16 squared, which equals 256 pi. Now they're asking me to leave it in terms of pi first and then round to the nearest tenth at the end. So I'm going to leave it as 256 pi. So it's the area of the small part over the area of the whole thing. Same thing for degrees. The degrees of the small part of the sector there is 36 degrees, and the degrees of the whole entire circle is always 360. I'm going to cross multiply, but these are kind of big numbers. It's going to be hard to reduce it at the end if I'm not careful. So I can reduce anything that's on the same side of the equal sign. You're not allowed to reduce across an equal sign. So here, if I divide by 36, I get 1. And also if I divide the bottom by 36, I should get 10. Those numbers are going to be easier for cross multiplying. So I multiply the area of the sector times 10, and I get 10 times the area of the sector that we want, equals 256 pi times 1. 256 pi. And the last thing we want to do is get the area of the sector by itself. All you have to do is divide both sides by 10. Divide both sides by 10. All right, so this answer is not reduced yet. I can divide both by 2. This turns into 128, and this turns into 5. So my reduced answer is 128 pi over 5. Remember, we're not going to turn that into a decimal since the pi symbol is still there. So I did it in terms of pi. Now I need to do it to the nearest hundredth. So I do 128 times the pi button. There we go. And then I divide that whole thing by 5. told me to go to the nearest hundredth, so I'm going to go 2 decimal places. It's 80.42 because that 4 does not make it round up. So it's 80.42, and since it's area, I'm going to say inches squared. The arc length is the distance along an arc measured in linear units, just meaning it's the distance from A to B in inches or feet or miles. Again, we're going to put the small piece, this red curve, on top of the whole circle, and we're going to just find the related parts. So over here, we're going to do lengths, and over here, we're going to do degrees again. So for the small portion, the length is what we want, the length of arc AB, from A to B, whatever arc we're trying to find. The length around a whole circle is circumference, so you want to do 2 pi r. For degrees, the degrees of the piece here is the same as the degrees of the central angle, whatever it happens to be, but the degrees of a whole entire circle is 360, so that goes there. So look at the next example, and let's just set it up. We need to make a proportion in order to be able to solve it, remembering that we're putting the small piece on top. In this case, it's just the arc information, and the whole circle on the bottom. So we're starting with the lengths. The length of RT is the one we don't know, the length of RT. That's what we're hoping to find. But we need to have the length of the whole circle. That's what goes on bottom. So that's the circumference. Circumference is 2 pi r. So it's 2 times pi times radius of 6, which equals 12 pi. And that's the circumference around the whole circle. That goes on the bottom. The small part that we don't know, the red part, is on top. The full circle is 12 pi. That goes on bottom. Now degrees. The degrees of this arc is 40 degrees, just like the central angle there, but the degrees around a whole circle is 360. Now to make it a little easier on ourselves, we can reduce right here. You cannot reduce across an equal sign. But let's see, you can cancel your zeros, of course, and then you have 4 goes into 36 9 times. So 4 divided by 4 is 1, 36 divided by 4 is 9, so that's what we cross multiply. The length of RT times 9 equals 12 pi times 1, which is just 12 pi. Now you want the length of RT, so you divide both sides by 9, and the length of RT is, you can divide or reduce both by 3. So if you divide by 3, you get 4. Divide by 3, you get 3. So the answer is 4 pi over 3. That's in terms of pi. Now to the nearest hundredth, we're going to do 4 times pi, and then we're going to divide by 3. About 4.19.